Dear friends, today we will discuss the effect of temperature on rate of reaction. When you consider this reaction, that is CH3I plus C2H5ONA will give the products. At different temperature, we have measure its rate constants. It will be seen goes on increasing as temperature increases. At 0 degrees Celsius temperature rate becomes like that. For 6, 12, 18 we have perform experiment and find out the rate constant. It is found that as the temperature increases, the rate constant will goes on increasing, and as you increases the temperature 10 folds, that is when you increase the rate of temperature of the reaction 10 degree, then rate of reaction will also increases 2 to 4 times. Therefore, how it is possible? Because as your temperature goes on increasing, your rate constant is also goes on increasing. We have the formula rate constant, rate of reaction is equal to K into concentration of reactant. Therefore, the rate is also depends upon concentration of reactant and also depends upon the rate constant. By observing this reaction, you can easily say that your rate is goes on, rate constant is goes on increasing as your temperature goes on increasing. Therefore, as like way, as concentration increase, as the temperature increases, your rate of reaction also goes on increasing. There is one rule is there, is given by the Van 't Hoff. That rule is called as Van 't Hoff rule. He given the gamma raised to n is equal to rate of T plus N10 upon K2. Okay, this is a rate constant at a temperature more than this, and this is another rate constant at temperature T, and this is rate constant at temperature T plus N10. Suppose for the sake of convenience, n raised to n is equal to, if it is at k is the 0, therefore k 0 plus 30, therefore k at 30 and k at 0. Lambda n, the rate constant at 30 degrees Celsius temperature and rate constant at the 0 degrees Celsius. When you put these values in this equation, lambda raised to, if it is k0 plus n into 10, n is the becomes will be 10, then it's 10 total t is the 30, therefore raised to n becomes the 3 in this case. Okay, because at 0 degree and the 30 degrees, n into 10 becomes the 30. Okay. Okay, it is found that n raised to gamma raised to 3 is equal to obtain the value 37.142. Okay, in this case we put the values 20.80 into 10 raised to minus 4. For 0 we will put the value 0.56 into 10 raised to minus 4. Then you will obtain these values, and by cube root of this you will obtain 3.32. Therefore gamma for the rate constant at 30 degrees Celsius temperature and rate constant at 0 degrees Celsius will becomes equal to 37.142, and its cube root is equal to 3.33. Van 't Hoff found that lambda value, gamma value goes on decreasing as our temperature goes on increasing. Therefore gamma is less, then rate of reaction will be higher. And now we find that there is a relation. The K is increases as the temperature is increases. Therefore K, that is rate constant, plays a very important role in find out rate of reaction. Later Arrhenius developed a equation. That equation gives relation between rate constant and the temperature. The differential form of this Arrhenius equation is delta lnk upon dt is equal to EA upon RT square. This is a differential form of Arrhenius equation. Arrhenius said that the reactor have to acquire a certain kind of energy for reacting and produces the product. That energy he called as the energy of activation. By gaining energy of activation, reactant molecules can able to produce the product. Therefore, for a certain reaction, energy of activation is a constant and fixed value. Now, we can say that the rate of reaction also depends upon the energy of activation. If energy of activation is less, the rate of reaction is higher. If two different reaction at same temperature, if you are carry out, the less energy of activation reaction will give the fast reaction, a fast product. Therefore, if the value of energy of activation is the less, then rate of reaction is higher. Therefore, we can find the Arrhenius equation by using Maxwell-Boltzmann distribution law. That law is a given as, if you have the reaction, A gives by acquiring activation energy, A gives the activated complex and activated complex gives the products. Remember that only activated complex only able to give the product. Directly from reactant it not give the product. Activated complex is responsible for obtaining the product. Therefore, number of activated complex is there, you will obtain the number of product. Therefore, how reactant molecules get activated? It gets activated that certain kind of energy when they got, then they will be converted into activated complex, and this activated complex is responsible for giving the product. And if activation energy is less, then definitely your reaction rate will be fast. Okay, now we got the idea. Activation energy is also responsible for the rate of reaction. Okay, rate of reaction is directly proportional to the activation energy. Okay, now because number of activation energy is the less, rate of number of activation it depends on, also rate of reaction is also depends on, you remember that the energy of activation. Now Maxwell given the rule, number of activated molecules. Okay, the rate of reaction is directly proportional to the number of activated molecules. NEA is the number of activated molecules. Number of activated molecule is A star is more, then you will obtain the more product. Okay, and these number of activated molecules can be given as the N is the number of activated molecules. Okay, number of activated molecule or fraction of activated molecules can be given by using Maxwell distribution law, Maxwell-Boltzmann distribution law. Okay, therefore fraction of number of activated molecules from total number of molecules. NT means the total number of N number of molecules. NEA means the activated N number of molecules is equal to E raised to minus EA upon RT. This is a Maxwell-Boltzmann distribution law which gives the how many number of reactant molecule got the energy of certain kind of energy of activation and will promote to the as a activated complex. Therefore it can be given by the Maxwell distribution law. Therefore number of activated molecules upon total number of molecules. Remember that total number of molecules. If suppose total number of molecules you consider NT is total number of molecules, therefore total number of reactant. Okay, total number of reactant is nothing but the concentration of reactant. Total number of reactant molecules is nothing but the its concentration. Okay, concentration. Okay, now by we have this kind of observation, rate of reaction is directly proportional to the number of activated molecules. Therefore rate of reaction is equal to directly proportional to the number of activated molecules. Therefore rate of reaction is equal to A, that is a proportionality constant we have used here, that is the called as the frequency factor. A called as the frequency constant, number of molecules. Okay, now in Boltzmann equation we can find number of activated molecules is equal to total number of molecules, that is NT into E raised to minus EA upon RT. R is the gas constant and EA is your activation energy. Now by putting this value from equation number 1, put NEA, that is the number of activated molecules, is equal to NT into E raised to minus E upon RT in equation number 2. Now you will obtain the equation A. This value is from taken from this. Therefore A into total number of molecules into e raised to minus Ea upon RT. Okay. Now we previously discussed that the total number of reactant molecules is nothing but its concentration. Therefore we can replace NT by the concentration. Now A into NT is your concentration of reactant, and into e raised to minus Ea upon RT. Now next A into E minus Ea upon RT into your concentration of reactant, that is rate of reaction. Now by comparing this equation, we have also one rate of reaction is equal to K into concentration of reactant. In this case, concentration of reactants is C. What about K? K is nothing but this value, because both the reaction are the same, equation are the same. Therefore this concentration is equal to C, and this K becomes the A. Therefore K rate of constant is equal to A into e raised to minus Ea upon RT. This is a exponential form of our Arrhenius equation, and when you take its derivative, you will obtain the differential form of the Arrhenius equation. We have studied earlier in this lecture. Okay, we have started temperature affects the rate of reaction. In this case, we have one rule, Went off half rule was there, and this rule is used for the reaction in solution, medium, and which is the reaction is which is performing at the low temperature. Only these two kind of reaction can studied under the Went off rule. Okay, that rule is given by the Went off. When your gamma is decreased, then reaction rate is increased. That first point we discussed, and the second point we have find out the Arrhenius equation in exponential form. Thank you very much.